I watched the video about pair programming last night. It was very interesting, and I think I can do something similar with Calcit Editor. It's also very uh, interesting, and actually the editor itself was designed to be a collaborative editor. Back at the time I was trying to make it. So here's some examples. Uh, so at first there's some background on Calcit Editor. It's an I will call it a tree editor. It's not the internally is factors expression representing expressions. It's not code. It's not text code like we normally do. Even there's code in my project, I can I can actually remove all my code. I can remove all the CLJS files and use opt equals compile and use Calcit Editor to compile the code. Now you may find all my code are back generated from the command line. The truth of the file stored in Calcit.eden file is it's a giant file for storing all the information. It's hash maps storing all the information. It was designed to be hash maps in order to be shared over network by the path. So you may already notice that if you want to modify the hash map, you just use the passes. Use the path. It consists of several strings, and you send to another one and the person, and it will edit the data in that path, like editing this text called define function. But if you use factors, you will get problems because some like several people can edit the same factor. You will mess up with the position. But it's a very huge file. I'm never going to edit the code by myself, so I use an editor called Calcit Editor. It was started on WebSocket server, and the UI part is actually online. Yeah, you can connect to the editor with Chrome browser tab. I use it in Chrome. Now I'm going to pretend that there are two persons connecting to the same editor, and we are browsing the same file, like component container, and as I browse the file in my browser, the other person will see where I'm looking at, and if I using keyboard shortcuts using keyboard to change the code, like just some data, say data and other data, and here I'll simultaneously see what I'm doing, and even edit my code. It's very simultaneous. So this is real-time collaborating. It's not based on text, so it's much simpler to use to build. And meanwhile, we need a project to demonstrate. This is the project I used to build my to-do list. It's a shadow CLJS project, and there are several builds like building clients, like building server. Let's start the watching server. It's like a Webpack dev server. It watches all the code and recompiles. It also how to replace the code at runtime. It's compiling using cache within the caches. catches. Now it's very fast. It started. Also, I need to start the server. All the pieces are compiled in target, so I can find server here and find client here. Now I can refresh the page to make sure the page is connected to server and connect to shadow CLJS. Suppose I want to edit the title here, this one. I would like to call it a work in progress, and I'm going to find the right component. The other person can find the component as well. He goes to the component and trying to find, and I find the word first, and I change it to working in progress. Shadow.js will refresh the page for me. It will refresh all the clients connected to the watch server. The other person might find that I'm using wrong character and he will just correct the letter for me. Yeah, working in progress. Let's go reverse the example. There are other things we can do, like I'm not going to edit the code. I'm going to watch others playing with the code. So I go to the members and click to watch this person. So then I want to set a bar. So then when I working in my editor, he will just see what I'm doing. I call it boss mode when I was creating it. It's like a boss watching. Say I want to change the color or the font. No, something or maybe like font. I change the font weight. Bold. See if anything happens. Nothing happened. Same color. I'll use white. Yeah, this is very obvious. I can try another color. I can revert colors, and the person on this side will just see the page because it's powered by shadow CLJS. It will hotly paste the code in the runtime, and he will see in the editor what I'm doing. It's in watching mode. This is I think this is enough to convince you that this edit is real time and it can really help you cooperate together. Also, there is another mode in Calcit Editor like client local. Use environment to control the behavior. To switch on local mode, it will start on server at 6101 this port, and let's try. So this is my IP address, and I can connect to and I can connect to the editor on the another IP address. What's more? Say I want to Calcit Editor. Calcit Editor is the very old name for Calcit Editor. I'm not looking for this example. It's using an outdated file. Topics. Pages. see if I can. Let's hope it's in the same. It's in the same shape. I'm running. Oh no. It's used the name. It used the name. So I use the same command line on the server. It's actually Calcit Editor. I'm going to maybe Calcit Editor. Yeah. Now I started Calcit Editor server on my server. It should work. It should work. Yeah, it works. It works. Now I can connect to the server. So you may find it's not my client local. It's not on my local code. I can kill my local server. I can kill my local server. Oh, so I need a host. Yeah, it's connecting to the server, and I can browse code in the server. So the code actually on the server, as I command save the files and kill the server. I can see it's saving my code in the project. Oh, seriously? Yeah. Mistake. Yeah, you see, I changed the number to 420. So which means I can launch my editor on a server with using command line and connect to the server and edit it with web page. So this is how you can do collaborative editing on a server, or even it's further running on your own laptop. I shall get it again. So this is my editor. You just see simultaneously see what's happening on other people's side. So this is about the demo, and I'm going to talk about a bit about how it works internally. I already mentioned this hash map in calcit.eden, the file. When you want to edit the file, it's actually dispatching. It's actually dispatching actions to the server, like edit, like write paste, copy message. So this is the logs I used to push, like changing the key, a text node. It's sending every keystroke to the server, and it's actually sending the string part of the result to the server to update each leaf. And the other clients will get the not get the message, get the state simultaneously to see what's happening. The tree was designed with by selection keys, which is my own library. It's representing a path with characters in this list. Say I use T and J for the key. Maybe I can find something YT. Yeah, YT or YT. There are several keys. So these keys has orders. When you compare YYT and YYJ, and the YYT is smaller than YYJ, so it's putting the expression before this, and so you can define its component container, and then counting with an expression, and then store and states. I can find exactly the same code in the editor. Yeah, just this code. I may try this one. Component cursor. Yeah. You may find the cursor create component states and console with a hash map, and then you see in the file its cursor prompt and the component prompt states, and then with an expression. The keys are in the same order because D is smaller than L is smaller than P, is smaller than R, smaller than T. The order of the keys decides which node is placed first. Then, in theory, it's just how this is working. So the problem of synchronizing the text turned into the problem: how do I synchronize the tree? So it's like JSON div and JSON patch, and it's even simpler if there's no factors. Yeah. Then with the orders of the keys, I think you may guess how it's actually working. Okay, I think this is enough for the demonstration. Thanks for watching.